All right, so here we are again. Let me take a moment to check and see. Oh, uh-oh. Uh-oh. Is OBS working? I think we're live. Hello, hello, hello. I think we're live. Hello, hello, hello. I think we're live. Chat out. Whoa. Hello, hello, hello. Okay, so interesting. Huh. Okay. All right, we'll begin. So the next question is, I think I've actually seen this question in a, oh no, I did it wrong. Oh, don't do that. New tab. I only wanted to go for like a couple hours, I think, today. I may have seen this question during an interview. We'll see. Design a time-based key value data structure that can store multiple values for the same key at different timestamps and retrieve the key's value at a certain timestamp. No, never mind. Different question. Implement the time map class. Time map initializes the object of the data structure. Void set string key, string value, int timestamp stores the key with the value at the given timestamp, timestamp. String get string key int timestamp returns a value such that set was called previously with timestamp underscore previous less than or equal to timestamp. If there are multiple such values, it returns the value associated with the largest timestamp previous. If there are no values, it returns the empty string. Okay. Time map set get set get. So we set foo bar 1, we get foo 1, gives us bar. We get foo 3, we get bar. We set foo bar 2 at 4, and we get foo at 4, we get bar 2, and then we get foo at 5, we get bar 2 again. Okay. Oh no, this is very similar to what I saw during an interview. Although I didn't get it right, I think the solution that I had. Key and value consist of lowercase English letters and digits. Timestamp is between 1 and 10 to the 7th. All the timestamp of set are strictly increasing. At most 2 times 10 to the 5th calls will be made to set and get. So at most 200,000 calls. Okay. Key and value are strings, it looks like. Okay. A value such that set was called previously with timestamp underscore previous less than or equal to timestamp. There are multiple such values, returns the value associated with the largest timestamp underscore previous. If there are no values, returns the empty string. So we can have a timestamp along with my input value. Well, also having kind of an injury on my mouth here. It's see me kind of like messing with my mouth, my tongue and my mouth. Okay, store with timestamp 1. So I think we can call the gets and sets sort of out of order in the sense that I can give it a larger timestamp, but then try to get something that has a smaller timestamp. If that makes sense. It's like I can go for a timestamp of 1 on foo after I put bar in there. After I put bar 2 in there. A value such that set was called previously with timestamp of previous less than or equal to timestamp. There are multiple values, returns the value associated with the largest timestamp previous. Oh, excuse me. So this largest timestamp previous that's less than or equal to that timestamp is the one that I want. Huh. So I'm trying to understand the behavior that I need. I'm pretty sure I could just use basic data structures for this, but just a combination of data structures. That should work fine. But the question is, like if you set 1 and then you get 1, you get 3. Then you set 4. and you get 4, that's fine. And then you get 5, it should return the 4 here. The largest timestamp previous that's less than or equal to this timestamp. Okay. Huh. Huh. I might want to use this a map for this. The value associated with the largest timestamp previous. Thinking if I call a lower bound or an upper bound on the keys of a map, what am I going to end up with here? So I think I need to sneeze. Excuse me. Yeah. The lower, excuse me. Oh my goodness. Oof. The lower bounds and upper bounds of a map. The question is, what does the upper bound? The upper bound will give me the first element that's greater than a particular value. The lower bound will give me the first element that's greater than or equal to an element. But I'm actually looking for the largest element that's less than or equal, which would be really that upper bound minus 1. Yeah. The largest element that's less than or equal. Yeah, just upper bound minus 1. Okay, we could try that. I mean, that works. Okay, let's go for that. Excuse me, it may not be the most efficient way to do this, but it's one way of doing this. Excuse me, unordered map, key to map of strings to actually the timestamp int to strings. This works. Just call it TM. Yeah, that should be fine. And then we just say set is going to be TM key dot insert, or no, key timestamp value. And then here we just say TM key lower bound, no, upper bound, excuse me, upper bound of timestamp. And then we got to decrement that by 1. And we want to get the value associated with that. Something like this. Something like this. I don't know if this will do exactly what we're looking for, but we could try it. Is it that simple? I don't know. Oh. Oops. What I just did. Oh. I did that wrong. I don't know what I was thinking. Sometimes I just kind of get so caught up with what's in my mind that I forget that's, yeah, okay. That probably works. There's a problem here. Hold on. We'll say point P1, find key, not P1. And then we can say P2, not P2. Actually, if P1 is equal to tm.end, I did this. I was gonna say this is too easy. Something's wrong. Something is wrong. Begin. Can this happen? What happens if I do this? Can this ever happen? So P1, find P2. These will never be empty the way this is set up, so I don't need to worry about that case. But also there is an issue of if I'm going to decrement P2, right, then it can't be the beginning, right? So how could it be the beginning? When would that, what does that mean? That means that the upper bound, which is the value that's greater than the timestamp I put in there. Basically it means that I looked at a timestamp before anything was in there. So I put something in at 3 and I made a lookup at 1. For example, timestamp 3, I put something in, and at timestamp 1, I tried to get something out at timestamp 1, but there's nothing in there before timestamp 1. That's this case. That can happen. I would return an empty value there too. And I could try these few different cases here. Ooh. Uh-huh. Uh-oh. What? Oh, because this is a pair? Okay. Oh, I see. Okay. So this should be the second value then. The pair. No? Maybe that's the issue. That could be it. C++ is tricky, man. Okay. We'll get a reference to the map, and maybe this shouldn't be a const. Okay. Wow. All right, let's try some other test cases. So, how about I set 2 here and see what I get there. That's kind of what I was referring to, that case where sort of something's not there. Yeah, there you go. So when you get, it should be empty. And then another one is here if the key is not there at all. Let's do another get. Let's do hello. 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 See what happens if I try to get something that's not in the map at all. Yeah. I think this is it. I am kind of taking a risk by not checking all of the possible like scenarios. However, what if you overwrite a timestamp? I think it can. I think it should overwrite a value's key value timestamp. Yeah. So if you put it, what happens if you put a different timestamp in there? I'm curious. Different value, different timestamp. Let's say I set. At foo, set new at 2. And I want to get foo 2 again. Foo 2, yeah. Let's try that. Foo 2, or even foo 3 should work. Let's try that one. Oh, okay. So no, you can't go back time in this way. All right. So there might be a way to modify this. Actually, that's better. You can get previous values, but you can't reset the values once they've been set. In that case, yeah, there may be a better way of doing this, but I'm gonna leave it for now. About 5, can I do that? There may be a better way. I'm gonna go for it. It could be wrong. It's probably some mistake somewhere. 1, 1, timestamp is 1. There could be, what about 0 calls? Just make sure I don't crash something here. Okay. Total number of calls is at least 1. Doesn't say it's at least 1. Check. Just try some unusual cases here, see what happens. Testing, testing, testing. All right, I think I'm gonna go for it. I think I'm going to go for it. Just gonna go for it. Could be wrong. Could be wrong. Oh, got there. Sweet. Yeah, that's pretty good. It's relatively fast. Yeah, I spent like a good extra, like a few extra minutes there, just kind of pondering it because I thought maybe it could be something wrong. All right. I forgot how long I've been going for and how long I want to go for. I think it's like 6:50 now. It's maybe been like an hour. Yeah, I think I started at 6. So I want to go till like 8 my time. 6 yeah. 6, 7, 8. 8 would be like 20 military time. All right, I'm gonna submit this a few times. The next one looks like minimum cost for tickets. Okay, go for that one. This is like reasonably efficient. There's probably a better way to do this, by the way. You know, I kind of just thought about it quickly and wanted to just make sure it was correct and then submit it. Yeah, I would guess there's a better way because, you know, it's not obvious how exactly the rules are for the keys. Like, you know, oh, 90% is pretty good. It's not too obvious what the rules are for the keys for like what you can update and what you can't update and all that. And so if you kind of spend a little more time pondering what you're able to do here, then you probably could use something slightly more efficient. But 90% is pretty good. That's not terrible. It's reasonable. 1, 2, 3, 4, 5. Yeah, this is logarithmic time per, like amortized logarithmic time per call, per get and set. So that's reasonable for the, and it's pretty quick to program, right? That was not bad at all. Had to kind of think about the edge cases a little bit, but overall it was relatively reasonable. All right, let's. Okay, so what I'm going to do now as mentioned, is I'm going to stop the stream and then start it again with another title. So we'll keep going on the next question. Yeah, if you like the video, don't forget to like it and subscribe if you like this kind of stuff.